In this video, we're going to be looking at absolute value equations and inequalities, and how do you solve absolute value equations and inequalities. An absolute value is the distance from its point of origin, often thought about as 0 from the number line, but it doesn't have to be. It's just simply a distance from its origin. Look to an example to see how to solve these problems. The first thing I want to do is isolate the absolute value so that I can split it into parts. So I will add 12 to both sides and get the absolute value of 2x minus 4 is equal to 28. Now that the absolute value has been isolated, I can split this into two parts, a negative and a positive. I'll work the left side first to get negative 2x minus 4 is equal to 28 and solve this side, giving me 2x minus 4 is equal to negative 28, or 2x is equal to negative 24 when I've added 4 to both sides, which means that x is negative 12. I've now solved the negative side, so I'm going to go work on the positive side. I'm going to put a positive outside the parentheses and have positive 2x minus 4 is equal to 28, which means that 2x minus 4 is 28. Adding 4 to both sides, 2x is 32, or when I divide both sides by 2, x is 16. This was my step 3, where what I did is I solved both equations. All that I need to do is express my answer. I'm going to say that x is negative 12 and 16, which is my step 4, to simply write my answer. We see in that example that solving an absolute value equation has two answers, to the left on a number line, or the negative side, and to the right on a number line, the positive side. I do this in blue, and I like to consider this part my red-blue wars, where I get to see which side comes up with which answer. Let's look at a second example that is an inequality. In the second example, I'm going to start in the same way. I'm going to isolate the absolute value. So having the absolute value of x minus 8 plus 5 is greater than or equal to 11, I'm going to subtract 5 from both sides to get the absolute value of x minus 8 is greater than or equal to 6. Now I need to split into my red versus blue, or negative versus positive. When I work the left side, I put a negative on the outside of the parentheses. So negative x minus 8 is greater than or equal to 6. Now I'm multiplying both sides by a negative sign, so I have to flip my sign, and I get x minus 8 is less than or equal to negative 6. Or when I add 8 to both sides, x is less than or equal to 2. I'm going to place this onto my graph with an arrow pointing to the left. I go to work my positive side, and I have that the positive x minus 8 is greater than or equal to 6. When I add 8 to both sides, I get x is greater than or equal to 14. And I'm going to place this on my graph as well. This has been my step 3, which was solve both equations, and my step 4, which is to graph them on a number line. Now all that's left is to express this as an answer, and I need to remember about my inequalities, my ands and ors. I'm going to get x is less than or equal to 2, or x is greater than or equal to 14. As with everything we've done, it's important to go back and substitute those answers into the original equations and make sure that they're true. There are a couple things that are noteworthy. One is that you have to remember about your and or inequalities. And the other is that an absolute value cannot be less than a negative number. So in the case of the absolute value of x is greater than or equal to negative 1, the answer is all real numbers because it's greater than. But if the absolute value of x is less than negative 1, then there is no solution. And remember, a ninja's pen has invisible ink, so you might be writing right on top of a ninja's math homework.